All right, guys. So on the previous day, we did two of these rules. The product rule, if nothing else, you can see right here in the shorthand how they designed it. They said, hey, if you have the same base, got to get this moving here for us. If they have the same base, you can see that they both had A right here. Then you just write the A right here. And then what do we do with the two little exponents, the M and the N? Well, you would add them together. So when you take a look at this situation, you can see that, hey, A to the third is timesing A to the second. That means they have the same what? Base. Wake up, wake up. So that means that we would literally write that same base right here. And then what do we do with their two exponents? Since they're multiplying each other, the rule said, hey, would you please just go through and add them? So in your head, you'd go 3 plus 2 is what? 5. And we talked about, hey, A to the third means there's 3 A's multiplying, and A to the second means that there are 2 A's multiplying there. So you put them all together, that's 5 A's multiplying, and that's why it's A to the 5th power. Now, if we look over here to this one real quick, we have the exact same thing again. All of these have the same, what's that word again? Base. And they're multiplying each other. You can see all three of them. So that lets us be able to just write that base for the answer right away. But what do we have to do for the exponents? Well, we go and add them. Well, 2 plus 2 is 4. The problem is that this last one had no exponent, so you can see I took the time to write that in. If you see no exponent, we always put a 1. So 2 plus 2 plus 1 gets us 5. Or if you wanted to know why, hey, the first x to the second gets us 2 x's. The second x to the second power gets us 2 x's multiplying. And the third x that has no exponent is still sitting right there as 1. So can you see we have 5 x's? That's all multiplying each other. That's why we call it x to the 5th. Now, we take the exact same idea right down here to this one, and we attack it the same way. Oh, look, oh, look, oh, look. What was our base that was the same on both of these guys? 5. So we put our base right there as a 5. And then in your brain, you say, well, I must add my exponents because they were multiplying each other. 5 to the 4th times 5 to the 2nd. Oh yeah, that'd be 4 plus 2. What's 4 plus 2? 6. Now the difference is we actually know what the base is this time. We know it's a 5. So you go to your calculator and say, hey, what's 5 to the 6th power? It's 15,625. Same thing's happening right over here when we take a look at the tens. Hey, we don't see an exponent on that first 10. I see an exponent on the second 10. Hey, they have the same base, so go ahead and write your 10 right there. Put a 1 right there, so that way you don't forget it. And 1 plus 3 is what? 4, 10 to the 4th, or 10,000. So that's our first row, our first rule of exponents. Does that make sense? All right, now let's go take a look at this next setup. I'm going to use a different pen here. Let's see. Yeah, this will be a little easier to write with. Do you see how this is A to the M power, and then we look on the outside of the parentheses and we say raised to the n power. A to the m power, what's that phrase? Raised to the n power. That's how we would actually read this. And what you do is you take your base right over here, see the A, and you would just write your A right there for your base. And then you go, wait a second, for this power rule, we have to multiply the inside and outside exponents. So m times n, we just multiply them together. So when we look over here at this one, what's our base right here, guys? What's our base? A 4. So we'll put a 4 right here. What on earth do we do with the 2 and the 3? Multiply it. So 2 times 3 is 6. There we go. 4 to the 6th power is 4,096. Same thing's happening right over here. This is our base, 3. 3 to the 4th power raised to the 2nd power. Since that's our base of a 3, we just write our 3 right here. And in our brain, we go, well, I must multiply the 4 and the 2, right? So in our notes, we've got the 4 times 2 right there. And that would get us 3 to the 8th, wouldn't it? And you know how to pull out a calculator and type that in, 6,561. So let's go take a look at the y. Well, it's not the hardest thing in the world. What was inside of the parentheses, guys? 4 to the 2nd power? Okay, so just write a 4 to the 2nd power here for me. Now, how many of this 4 to the 2nd power is it going to happen? What's my outside exponent? 3. So how many 4 to the second powers are really going to happen? 3 of those suckers. So it's going to be 4 to the second power times 4 to the second power times 4 to the second power. And I don't know if you remember this, but if you scroll right on up here, if I had 5 to the fourth times 5 to the second, don't I keep the same base? And then what do we do with the exponents in this situation? Add them. Well, can't we just do this? Can't we just keep the same base since every single one of these is exactly what? 4? Yeah. So that would let me be able to write a 4 for the base. And then what would I do with the 2, the 2, and the 2? I would add them up. It's another way of doing it. Now that's cute and that's nice. But what happens if you have 4 to the second power raised to the 100th power? I don't think you want to copy that one down 100 times. So that's where the multiplication really pays off there. Okay, so when you see the parentheses, you want to multiply the inside and outside exponent. Okay, and you stick that to the base that's shared there. Let's go over to the next set right on down here. Do we feel good about all of this right here? Do we feel good? All right, so let's move on down to the next rule right here. Again, this is review, but it's usually forgotten, and we just handle it. This is called the quotient rule, and this time I did not put any jargon underneath to kind of explain it. So let's go see if you guys can make sense of it. If you have an A on top with an exponent, and then you have the same base, let's just call it an A on the bottom with a different exponent, what would you do with the exponents in your brain? Subtract. Now, which one do you put first, the top exponent or the bottom exponent? You can see that the M is placed first and the N is placed what? Second. So you want to make sure that you pay attention to that order. And now let's go see if we can do this. Hey, do we both have the same base on top and bottom? Yeah. So that's just like the A. Here's an A. Here's an A. So we write a A. Here's a 5, here's a 5, that's the bases, they're shared, so we write a 5. Now, I want you to go ahead and write the top exponent of this 5, 3 right here, put a minus sign, and we write what? 2. Ladies and gentlemen, what's 3 minus 2? 1. What is 5 to the first power? 5. 5 to the first or 5 is the exact same thing. Could you all do the second one for me real quick? I'll pause. Now, I noticed they had the same base, so I put a 70 there. Did you all put a 70? And then how about a 6 minus 3? So what did we get? 70 to the third power. Who's got that for me? Very good. 343,000. Now, personally, I like the 343,000 answer the best if you have a calculator. Now, if you go home at night and you don't have a calculator, and you show up and you say 70 to the third power, and you say, Mr. Ted, I didn't have a calculator, I'm going to give it to you. Okay? So we can work both ways, but it's usually best if you've got a calculator, cell phone, work out that answer for me. If your base is a number, you should be able to figure out what the final number is. Okay? Now, if we look down here and your base is not a number, then the next thing you need to do is you'd be like, oh, cool, I don't have to do anything else. It's just here's my E, and then it'd be what? 8 minus 3, so it'd be E to the 5th power. Hey, guys, what's my exponent for this bottom F down here? What would my exponent be? 1. So go ahead and write the 1 so you don't forget about it. Remember, that's a big, big, big deal. So how about we just say, hey, F 13 minus 1 appears what we're doing in our brain, and this would be F to the 12th power, and then we just box it up there. On your assignment tonight, do I have to see where you're subtracting the exponents on there? I don't. If you are trying to get to the point where you can memorize this, it would actually do you a lot of good to write that out real quick before you get to the answer. It lets you see it on paper, and that will help you. Okay? All right. At this point, I'm going to end this video. So that way I can just label this one up as lesson 2, page 2 of the notes. I'm going to pass out page 3 to you, and we're going to finish that up real quick. Okay.